Welcome to part 4 of Unit 4. And so in the first few parts of Unit 4, we talked about how to know if polygons, or more specifically triangles, are congruent. And we said that in order for the triangles to be congruent, that all corresponding parts of the triangles must be congruent. Well, here we're going to come up with some shortcuts and some things that we would only have to prove certain parts in order for the two triangles to be congruent. And the first shortcut is what's called the side-side-side postulate. And that basically says if 3 sides of one triangle are congruent to 3 sides of another, then the triangles are congruent no matter what. You don't have to prove the angles. So for example, it says given QU is congruent to AD and QD is congruent to AU. So those are marked. And it says provide the reasons to show that triangle QUD is congruent to triangle ADU. So why is QU congruent to AD? Well, they gave it to you. Why is QD congruent to AU? It's also given. Why is UD congruent to DU? Well, that's the same segment, so it's what's called the reflexive property. And then why would the two triangles be congruent? That is because of the side-side-side congruence. So 31 says use the side-side-side congruence to show that triangle ABC is congruent to triangle DEF, where, and it gives you the coordinates for each vertice. So what you have to do is find the length of each segment. So you have to find AB, so you're going to have to do the distance formula. So remember the distance formula is x2 minus x1, so 0 minus negative 5 squared, plus y2 minus y1. So it's going to be the square root of 0 minus negative 5 is 5, so 5 squared. 3 minus 5 is negative 2 squared. So it's 25 plus 4, so it's equal to the square root of 29. You do not need to calculate that because you're just trying to show that it's the same. So you're hoping to get the same radical. So this is the square root of 29. Then we can do AC. So we get negative 4 minus negative 5 squared plus 1 minus 5 squared. So negative 4 minus negative 5 is 1 squared. 1 minus negative 5 is negative 4 squared. So 1 squared is 1 plus negative 4 squared, which is 16. So it's the square root of 17 is AC. And then BC. So BC, you go 0. So we'll just do x2 minus x1. So we'll go negative 4 minus 0. And 1 minus 3 squared. So it's negative 4 squared plus negative 2 squared. So it's 16 plus 4, which is the square root of 20. We could simplify the square root of 20, but we don't really need to. At this point, we could make it 2 rad 5. So then we have to do the other triangle and hope that they match up. So here we'll find DE and hope that DE matches to AB. So DE 1 minus 6 squared plus negative 1 minus negative 3. So it's the square root of negative 5 squared plus 2 squared So it's the square root of 25 plus 4, which is the square root of 29. So DE does match AB. So far, so good. Now we have to find DF. DF, we go 1 minus, we go 5 minus 6 plus 1 minus negative 3. So it's going to be negative 1 squared plus 2 squared Sorry, 1 minus negative 3 is 4 squared. So it's going to be the square root of 1 plus 16, which is the square root of 17. So DF does match up with AC. So we have one more. We just have EF. And EF is 1 minus 5 squared plus negative 1 minus 1 squared. So it's negative 4 squared plus negative 2 squared equals 16 plus 4, which is the square root of 20. So therefore, we've shown that all the corresponding sides are congruent, so therefore the side postulate works. The next one is what's called the side-angle-side congruence. And that's if two sides and the included angle, so included angle means it has to be between the two congruent sides. So notice since AB and is congruent to DE and EF is congruent to BC, the included angle would be the angle between them. So notice B here is between them and E there. That is the included angle. So that's what leads it to be side, angle, side. Side, angle, side. So if two sides and the included angle of one triangle are congruent to the corresponding two sides and included angle of another, then the triangles are congruent by side, angle, side congruence. So 32 says the wings of one type of moth form two triangles. Provide the reasons to show that triangle FEG is congruent to triangle HIG, where G is the midpoint of EI and FH. So why is the G the midpoint of EI and FH? Well, that was given to you in the statement. Why is FG congruent to HG? Well, that is the definition of a midpoint. Midpoint divides it into two congruent parts. Why is EGF right here congruent to IGH? And that's because those are vertical angles, so it's the vertical angles theorem. And why is EG congruent to IG? Well, that is also definition of midpoint, because G is the midpoint of both segments. So notice you have side, angle, side, and side, angle, side. So the two triangles are congruent by side, angle, side congruence. All right, let's look at another proof. This one is in a quadrilateral. It says that RQ is parallel to TS. That's what the arrows mean, is parallel. And then RQ is congruent to TS. So those two things are given to you. Now, because RQ is parallel to TS, angle QRT, so this angle right here, is congruent to angle RTS. And the reason for that is alternate interior angles. theorem, because if the lines are parallel, alternate interior angles are congruent. So the alternate interior angles theorem. Then we have a side and angle, and then notice this side is the same in both triangles. So we can say RT is congruent to RT because of the reflexive property. And then triangle QRT is congruent to triangle STR. Notice we have side angle side congruence. And last, it's saying, well, after the triangles are congruent, then why is angle Q here congruent to angle S? And the reason why is if the triangles are congruent, then their corresponding parts are, so CPCTC. So after the triangles are congruent, you can then say any of the corresponding parts are because of CPCTC, which is corresponding parts, congruent triangles are congruent. All right, so let's look at some more examples here. It says, determine which postulate can be used to prove that the triangles are congruent. If it's not possible, then state that. Well, here notice you have side, angle, side, side, angle, side. So this would be the side, angle, side congruence. But notice here you have side, side, angle. That's different. So therefore, it is not possible because the ones we only know right now are side, 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 and side, angle, side. Here you might say, well, you only have two sides. That's true, but notice they share this side here. So therefore, it becomes side, side, side congruence. Because you can assume from that picture that that side's congruent to itself. Same with this one. This would also be side, side, side congruence. And then this one as well, notice it is side, side, side congruence. Nope. Okay. Given angle A is congruent to angle R, what sides must you know to be congruent to prove it by side, angle, side? So basically, if angle A is congruent to angle R, then it has to go A, B, C. Here's A, and R, S, T. So then you would need to know that AB is congruent to RS right here. And you would also need to know that AC is congruent to RT in order to make it side angle side. All right, so that concludes our video for side angle side and side 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 congruence. Part 5, we'll talk about another shortcut.